In 2017, the Earth came across a very unusual object. We did not know it then, but our planet had been visited by something that traveled from far out in the void of outer space, from another star. It was something we'd never seen before, and it's taken us years to determine what that object actually was. Now, in 2025, everything is happening again. Another odd visitor is heading for our sun. This time, however, we can watch it coming, and things are about to get even stranger. Let's start at the beginning. This is Oumuamua. It's the first interstellar object ever detected, meaning that it came from another star. Then it spent millions of years traveling through space on its way to encounter our own solar system. But still, this one caught us by surprise. At the time we finally identified the object, it had already made its closest approach to the sun, and it was headed out of the solar system back into space. Oumuamua owes its name to the Hawaiian observatory, which first spotted it. At first, they considered it just another comet, but upon further examination, they saw that it didn't have the characteristic tail of a comet traveling through the solar system. Therefore, it must be an asteroid. Only this object was acting too strange to be just another space rock. It was moving too quickly. That is the first sign that we are observing an interstellar object. All that is within our solar system is bound by the gravity of the sun. All the planets, comets, asteroids. We are all just revolving around this tremendous force of gravity. And the only way we could possibly escape the solar system would be to speed up, to achieve escape velocity. That is contingent upon how close you are to the sun. But from the Earth, escape velocity would be about 42 kilometers per second. When we first spotted Oumuamua as it passed beyond Earth's orbit on its way out of the solar system, it was moving at 87 kilometers per second, way too fast to be caught by the sun's gravity. That's what we call a hyperbolic trajectory. And what's really interesting is that before Oumuamua passed by the Earth, it flew so close to the sun that it was actually inside the orbit of Mercury. And what's more interesting is that so close a pass with such a strong force of gravity should have decelerated the object down. But what we saw was that when Oumuamua passed away from the sun, it actually speeded out of the solar system. This is where the name Oumuamua originates. In Hawaiian, it means the first to extend or the first, far-off messenger. Usually, we abbreviate the translation to simply scout. So, we've got levels of awkwardness here, and this is merely scratching the surface. If the object in question was simply an interstellar asteroid, i.e., a rock, then its trajectory should be regulated by the laws of physics, and physics dictates that going by the sun would have decelerated it. So, if that didn't occur, then it means some other force emanating from within the object itself must have acted to alter its speed. So that means it's physically impossible for this thing to be merely a rock. It must be something else. And the next degree of strangeness is that not only was Oumuamua moving through space in a manner that we've never experienced before, but it also appeared rather peculiar while doing so. When we attempt to create a picture of something in outer space, all we really have to go on is sunlight being reflected off of it. Giant bodies like Saturn and Jupiter reflect a giant amount of light, and that allows us to see them clearly even though they are really far away. But when it comes to something relatively small like an asteroid, all we see is the faint little blip of light reflecting off that object. Most asteroids are not very reflective because they are just rocks, and they are mostly round in shape. So, we expect to see a relatively consistent and dim reflection. Oumuamua did something unexpected. For one, it's a very bright object, highly reflective, indicating that it's probably not made of rock. And thing two, as we observed this light in the sky, it was not consistent. It was pulsing from bright to dim and back again once every 7 hours, meaning that the object can be round. Like an asteroid, we are seeing a long side and a short side. This caused astronomers to come to the unlikely conclusion that the object was most likely long and slender like a cigar and it was slowly rotating end over end as it traveled through space. Even this would have to be disputed by an object which was saucer-shaped, broad and flat and thin, also rotating as it traveled. But informing people that you saw a flying saucer which came from another star would begin to sound a little crazy. Unless that is actually what happened, in which case, aliens. Is MUA an alien spacecraft? This is the point where the History Channel would try and tell you that it is and it could be. But we are just here to present what we know and let you make your own decision. But this is a bit strange. People get fixated on how Oumuamua appears, and it is strange. But don't forget, it's actually the object's unexplained shift in speed that makes it so unusual. It's what provides some validity to the alien theory. So, here's the thing. It's natural for a comet to speed up when it goes through the sun because comets are basically just huge lumps of ice that originate deep out in our solar system. The Oort cloud. There's all sorts of bizarre random frozen material out there. It's like the bottom of your deep freezer. Every now and then one of them comes. The inner solar system, and as it approaches the sun, the ice starts to change into gas. This is referred to as sublimation, which is not the same as melting because the ice never turns into liquid, it goes directly from solid to gas. That's what creates the fuzzy halo, also referred to as the coma, and its tail. There's also a considerable amount of dust that gets released when the ice sublimates, too. In any case, that all of the offing will function just like a thruster on a spaceship. So, if the sun is warming one side of the comet, it's going to propel more gas out in that direction, and the force will nudge the object and alter its orbit and velocity. But Oumuamua had none of these comet-like visual features. No coma. No tail. No visible outgassing of any sort. But it acted in a very comet-like way, which would lead some individuals to think that this really was a spaceship with thrusters. Now, let's discuss where Oumuamua originated. Its path is directed towards the star Vega. It's the brightest object in the constellation LRA, which rises over the northern horizon. Vega is not any dull star. It's been studied in depth by astronomers for many years, and it's commonly called the most significant star in the sky after the Sun. That's interesting. 14,000 years ago, Vega actually was the Earth's northern pole star, the North Star, a fixed point of light in the dark night sky that has been employed for navigation likely since the beginning of man. The North Star varies with the passage of time as the Earth gradually precesses around in the universe. Currently, it's Polaris, but it will shift back to Vega sometime around the year 14,000. Now, there is no evidence to indicate that Oumuamua originated Vega's system. It just came from that direction, which by chance is the same direction that our solar system happens to be moving. So, as hard as Oumuamua hits us, we also kind of hit it. We'll talk more about how things move around the galaxy in a minute. As Oumuamua orbits our sun, it begins heading straight towards the Earth. This is where some will say that the coincidence in it is really begin to add up. Asterisk this weird thing from somewhere far, but historically interesting location in the universe, acting this weird and inexplicable way, and it flies directly past us. Close is relative in space, anyway, but it was still 24 million km away at closest approach. To put this in perspective, the moon is 400,000 kilometers away, so be 50 times the distance to the moon. But perhaps an ancient alien probe from an advanced civilization can still see us from very far away. This is where our telescope spotted Oumuamua for the first time, a few days after the closest approach to Earth, as it's already on its way back out to interstellar space. So, as close as it came, we never really got much of a chance to study Oumuamua, or even try to determine just what exactly it even is. There have been suggestions thrown around about sending a probe to catch up with Oumuamua and trying to study it, but the object is moving so fast and it has so much of a head start that no chemical rocket engine could possibly chase it down. We'd have to work out some complex bit of orbital mechanics where a probe would just fly to Jupiter, use a gravity assist off the planet to fall into the Sun, then ignite its engines as it flies past the Sun to slingshot itself out of the solar system in the same direction as Oumuamua. And that's never going to happen. If Oumuamua had been the one and only interstellar object we'd ever see in our lifetime, then something like that might have been worth it. But within a little while of that initial contact with a fragment of the far-off galaxy, something strange began to happen. We were visited again in 2019. A second interstellar object was seen. This one was called Borisov after the amateur astronomer who first made the discovery. Like Oumuamua, Borisov was approaching on a hyperbolic path, too swiftly for the Sun to capture, and Borisov came from the same general direction of the northern sky, this time emerging from the constellation Cassiopeia. Unlike Oumuamua, however, Borisov is certainly a comet. It appears to be a comet. It acts like a comet, and as far as we can tell, it's composed of very similar material as the comets that exist in our own solar system. Still quite cool, but nothing mind-blowing. Although it is fascinating that we very suddenly went from not having any interstellar objects for the whole duration we'd been looking at the night sky, and then we get 2 of them within 2 years, and then there was 3. This is our newest guess 3 Atlas, meaning third interstellar object, and it was found by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is an autonomous robotic survey that detects near-Earth objects. It was spotted on July 1st at a distance of 4.5 astronomical units away from the Sun. An astronomical unit, or O, is the average distance between the Earth and the Sun. We use that like a solar system measuring stick. So 3I Atlas is 4.5 times further away from the Sun than the Earth, which means it's just past Jupiter, but still really far away from Mars. The cool thing about 3I Atlas is that we caught this one on its way into the solar system. So, we are currently watching it approach the Sun for the first time. What stood out initially about this object is that it's really big and it's moving really fast, much faster than Oumuamua, and it's coming from an entirely different direction. While we basically hit Oumuamua and Borisov hidden, Atlas is coming in from the side, like a T-bone collision, and that means Atlas originated in an entirely different part of the galaxy, somewhere distant, ancient, and very unlike our own cosmic neighborhood. Okay, we're typically used to seeing our Milky Way galaxy from this perspective, top down, and that's us right here, pretty much halfway in between the core and the outer rim. But from our perspective, the galaxy looks more like this, a side-on view. We've got a big sphere-like core, also known as the bulge, and it's surrounded by a relatively flat disk of stars and planets and gas and stuff that's all swirling around like a spiral. The vast majority of those stars are located in the very center of the plane. We call this the thin disk. It's where our Sun is located, but just above and below the thin disk is much less dense and more diffuse layer of stars called the thick disk. Because there's less star-forming activity up here, objects in the thick disk are much older remnants from the galaxy's early days. And then beyond the thick disk, there are these random clumps of star formations that we refer to as globular clusters. Those are probably really odd, but we're not venturing that far today. The reason you want to know this is because 3 Atlas seems to have come from the thick disk, and if so, then this could be an unfathomably old object. On the high side, it could be older than 7 billion years, older than our own solar system. So, that alone makes 3 Atlas a very intriguing object. But there are 2 more factors involved that add to the mystery even more. One is size. This object is actually huge. First reports estimated the diameter at up to 20 kilometers wide. And as we went on to watch Atlas, we began to realize a bit more of what we were seeing. It soon became apparent that this object does have a coma around it, a cloud of dust and gas, which means that it's not a hard object like Oumuamua. It's actually an interstellar comet like Borisov. So the coma is 20 kilometers wide, but the nucleus, or the solid mass of frozen stuff in the middle, could still be as big as 11 kilometers across. That would be 10 times the size of Oumuamua and 5 times the size of Bursov, so they are getting bigger. And thing number 2. This is probably the strangest fact about Atlas, is its trajectory. Since this object is hitting us from the side, it's going to have the chance to come close to several planets along the way. The object will have its closest approach with Mars, within approximately 28 million kilometers, then it's going to come fairly close to Venus, 97 million kilometers, and when it exits, 3I Atlas will fly past Jupiter at a distance of only 53 million kilometers. So, it's having some high-quality sightseeing on this journey. But by coincidence, 3I Atlas is going to bypass the Earth completely. We'll actually be on the opposite side of the Sun from the comet as it passes through the inner solar system. That implies our telescopes will lose contact with the object in October this year, and we won't be able to observe it again until December, at which time it will have already had its closest approach to the Sun and will be heading out of the solar system. Now, just such as with the bizarre action of Oumuamua, it might be argued that the planetary grand tour of 3 Atlas is not a coincidence, that it could be the intentional action of an alien probe, one that is attempting to learn as much as it can about our solar system, while at the same time staying out of close observation from the sole inhabited planet by hiding behind the Sun. Even with an open mind, that one feels like a pretty big stretch. If an ancient alien species actually sent a probe all this way across interstellar space that traveled for billions of years and had the opportunity to check out a planet that was covered in life and home to an advanced civilization, but then they just shy away from us at the last minute. Anyway, the cool thing about 3I Atlas is that we still have a couple of months to observe it as it gets closer and nearer to the inner solar system. And so, in time, much of the mystery will be turned into knowledge, and as opposed to Oumuamua, we may still have a chance at intercepting Atlas. Now, we likely can't get anything constructed and launched from Earth quickly enough, but we do have spacecraft already in orbit about Mars and Jupiter. So, there is a possible situation where one of the Mars orbiters shifts out to attempt and get as close to Atlas as they can. There's even a possibility that the Juno spacecraft breaks away from orbit around Jupiter and encounters Atlas in deep space next spring. That's not going to happen, but it would be nice if for no other reason than to just know for certain what it is we are viewing. If we could have done the same from Oumuamua, then we'd likely have a whole lot more answers and a lot fewer questions today. But even without having sent out a probe, we still have some pretty decent ideas. So, presuming Oumuamua wasn't an alien ship, it could well be a comet. If a comet is merely a chunk of frozen material, then there's no rule as to what that material has to consist of in our solar system. From the comets which we observe are usually composed of frozen water, which sublimates into gas and forms the characteristic tail, because water vapor is usually easy to notice, such as steam for instance. But not every gas is so easy to spot. Nitrogen makes up almost 80% of the air we breathe. It's colorless, odorless, and usually not noticeable. But it does make plants grow. So, it's significant stuff. And there's one very common object that's nearly all composed of nitrogen. It's Pluto, the object once known as a planet. Most of Pluto's surface consists of nitrogen ice, which is a big part of the reason why Pluto was considered to be a planet in the first place, because frozen nitrogen is highly reflective. So, when you look through a telescope, Pluto appears big and bright, but it's actually less than 2,500 kilometers across. It's much smaller than our moon. Now, imagine this scenario. Pluto gets struck by a giant asteroid or a rogue planet and it shatters into jagged little bits. One of them gets launched towards the Sun at incredible velocity. Now what we have is a hunk of frozen material traveling from the outer solar system inwards. Basically a comet by most definitions other than this one is composed almost entirely of nitrogen ice. So, it's going to begin melting or sublimating technically as it heads towards the sun, and the ice will change state to gas. But since nitrogen is invisible and unreactive, we won't actually notice any coma or tail forming the object. But that doesn't mean that it isn't there. It is. And then, as the shard of Pluto approaches the sun, increasing amounts of gas are released, and the object's natural thruster system gets cranked up. And in this entire chaotic mess, the sun's gravity winds up shooting the shard out of the solar system and into the expanse of interstellar space. That's MUA, if that kind of situation occurred in some far-off star system, perhaps the Vega system, and gave some strange shard of frozen nitrogen from a destroyed dwarf planet, and then that thing crashed into our own solar system and passed by our sun. And then it would have appeared and acted a lot like OumuMua, or someone created a 100 meters long cigar-shaped tumbling space probe and sent it hurtling at our solar system, only for it to go sort of close to the Earth, but not really close at all, and then us take off without really doing anything are yet to come. Stay tuned.